Monica, could you please read question 6 again?
In an experiment using a ripple tank, plane waveforms arrive at the plane surface. Which row correctly describes the waves after they are reflected from the surface? Speed of waves. Mm,
So which one? Which one is the answer?
um,
Yeah, Mahi, you know the answer? Mahi, you know the answer?
Sir, B,
Bangladesh or Dhaka?
Bangladesh.
Bangladesh, okay. And Monica, you got your answer?
yes, sir.
Yeah, what is your answer?
Bangladesh.
You also got Bangladesh, okay. Now, what is happening here? Yeah, reflection or refraction?
Reflection.
Hmm?
Reflection.
Reflection.
Reflection, okay. If it is reflection, then it's returning back to the same medium, right?
Mhm.
You both got your worksheet printed, right?
Yes, sir.
Okay, right here. In reflection, wave returns back to the same medium. In the same medium, in the same medium, speed speed is speed of the wave is same. Since the frequency remains same always, the same source wavelength also will be same. Also the same. So can you read the statement I wrote, Mahe?
Yes, sir.
The statement I wrote, can you read please?
Okay, sir. In reflection, wave returns back waves for the same force, wavelength will also be same.
Is it clear?
Yes, sir.
So what should be your answer now?
Sir, D.
Dhaka.
Yes, sir.
And what about Monica? Monica, what will be your answer?
Dhaka.
Yes. Now the answer you chose. When it will be the answer?
When it's reflection.
Refraction. It is refraction, and we got also another idea like shallow and deep water,
Mm,
right? So water wave will go from shallow to deep or deep to shallow.
Shallow. Sorry. Deep to shallow.
Deep to shallow. Very good. Very good. So now you understood it, right?
Yes, sir.
If there is medium change, then you will have the speed change. Otherwise, speed will remain same. And if your speed is same, then wavelength will be also same, right? We have the
Yes, sir.
formula of speed, frequency, and wavelength. What is the formula? What is the formula?
V is equal to F lambda frequency
Frequency
lambda.
by wavelength.
Yeah, F lambda, this formula, right? So frequency is always same for the same source. Now your wavelength will change if the speed is change, right?
Mhm.
Yeah.
Yes, sir.
So Monica, please send it to our group. Yeah. Thank you. Now we are going to next question. Here, can you read it, Mahi? Question 7.
Okay, sir. The diagram shows a ball floating in a tank of water. Which diagram shows the movement of the water as the wave passes?
Yeah, which one is your answer?
Answer B.
When it is B or D, you say Bangladesh or Dhaka. Which one?
Sir, Bangladesh.
Bangladesh. You are choosing Bangladesh. Okay. Then Monica, what's your answer?
Mm, it's C.
Is C. Okay. So, why you are choosing C and why you are choosing B? Can you please explain? Yeah, first, Mahi, can you explain why you chose B?
Oh, sir, because when the wave goes the other side, the ball doesn't move. It only moves left and right.
Mhm. So water wave is transverse wave or it's longitudinal wave.
Transverse.
Okay, in transverse wave, the vibration of the molecules is forward, backward, or up and down.
Oh, up and down.
Yes, transverse,
Sir,
right?
yes, sir.
So if it is transverse, still your answer is Bangladesh, or you will change it.
Sir, D.
Dhaka.
Yes, sir.
Okay. We can now choose either. We will not take A or B, right? Now
Yes,
we
sir.
have to focus here in C and D. Now in between C and D, which one will be more appropriate? That one we have to find, right? Now you
Yes,
see
sir.
the wave, how it's going. Its particles movement is the ball's position. You see, if you think it is rest position, then the wave particles are moving up and down, right? Isn't it,
Yes,
Monica?
sir.
So, what do you think, Monica? You still in C or you'll choose D?
D.
You will choose D. Okay. So why we are choosing D? Because our particle vibration is up and down, right, from the rest position. That's why ball will also act accordingly. Is it clear?
Yes, sir.
So it is transverse wave, the first thing, and second thing is the particles movement is up and down from rest position. These two information you write. Is it clear?
Yes, sir.
So you
Yes,
wrote
sir.
it. Have you written?
Mm,
Very good. Now question number 8. Yeah, Monica, you read question 8.
The diagram shows the pattern of waves in a ripple tank. What does the pattern shows? Waves being reflected.
We
Waves
do
being
A.
reflected. A. It's very
Yes,
easy,
sir.
Any
right?
time. Yes,
Yes,
sir.
sir.
Very easy. This one is very easy. Other options are wrong because waves not changing speed, waves not changing frequency, and it's not reflection. It's reflection. Okay. Question number 9. Yeah, Monica, continue. Question 9.
A boat moves up and down repeatedly as a water wave passes it. Which name is given to the number of up and down movements of boat per unit time?
Yes, which one?
Frequency.
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 Yeah, Mahi,
Yes,
what's your
same.
answer?
The same. D.
Same.
Frequency.
It's up and down movements means complete cycle, right?
Yes,
Yes,
sir.
sir.
Complete cycles per unit time, so it is frequency. The next 10. Yeah, Mahi, continue this.
In a ripple tank, a vibrator produces a circular waveform which hit a flat surface. Reflected waveforms are also part of circle, where is the center of this circle?
Okay. So, what could be the answer?
Yes, I'm confused in this.
Yeah, this one is a little bit confusing because they are now dealing with water waves, but you did not learn about water waves image properties. You learned about properties of image on a plane mirror, right? Isn't it?
Yes,
And
Yes,
yes,
there
sir.
you
yes,
got one property that object distance and image distance should be equal, isn't it?
Yes, sir.
Can you remember that we got this property that from the mirror
Yes,
the object distance and image distance should be equal. So we are now using that idea here. How? Like they are asking you the reflectant reflected wavefronts are also part of circles. Where is the center of these circles? Okay, so we are using the idea of that reflection here. Like if it is reflected, if the wave is reflected, then what could be the possible shape of the uh, wavefronts? It is returning back, right? So now here is the vibrator, and we are getting the waves, circular waves, and it's reaching to the reflector. Then our wave will return back like this, opposite way. Okay, wave will return back like this. Okay, as if the center. This is dotted lines so that we can get the virtual, right, virtual shape of the rings or the circles this way, huh? Then if we are taking this as the circles, then where will be the center of circle? Here at A. Is it clear? Hello?
Yes, sir.
Yeah, and
Yes.
we are using simply the simple way to get it, that the properties of image on a plane mirror, we got object distance and image distance should be equal, right? So where they are saying, where you are asking, they are saying where is the center of the circle, that means that is the position of the image, right? Because they are saying the circle where the reflected wave fronts are coming, right? Mahi, Mahi,
Yes, sir.
now your confusion gone.
So can you explain it again?
Yeah, I'm explaining. Look, if it is reflecting back, these waves, if these waves are reflecting back, then the reflected waves will be like this, right?
Yes,
Isn't it?
sir.
And
Mm.
if we show it here, the reflected waves here, then you see it's forming a circle, right?
Yes, sir.
And we are showing here dotted lines to form the circles. And if you complete the circle, you see that center is here at A. Center is here at A. So
Yes.
this is one explanation, and other technique is to use the properties of image on a plane mirror. There we got object distance and image distance are equal. So here is your vibrator. Here is your vibrator. It is object, right? Hello.
Yes, sir.
This is source of your wave. So it is object, we can say. Then here is the image position, right?
Yes, sir.
And from the reflector, you see A, that is image position, and D, which one is object position, are equal. The distance are equal from there. Is it clear now?
Yes, sir.
Yes,
So we
sir.
are using this. This is a very rare question. Only one question like this I got so far. So here I gave the hints. The reflected waves must appear to come from the position of the image. So that property we used here. Can you take the snap, Monica? Okay, now we are going to next part. Yeah. Question number 11. Monica, continue.
Which statement about waves is correct?
Yeah, which one?
Waves, C. C.
C, correct. So
Waves transfer energy without transmission.
this one we got at the beginning, right? At the beginning of this topic is
Yes,
written,
sir.
right? Mahi, you understood it? 11. Your answer is also C.
Yes, sir.
Okay, then 12. Mahi, read 12.
The
Tell us the
plain
answer.
water waves travel from a shallow region into a deeper region. They travel more quickly in the deeper water. The diagram shows the wave pattern in the deeper water. Um, which diagram shows the wave pattern in the deep?
Yeah, which one?
Sir, A
A.
or B?
So what is the idea you got? If it is going to deep, what will happen? Speed will increase or decrease, or will be same?
Are we same?
Shallow water to deep water, your speed will be same.
Oh no, sir. It will increase.
It will increase. If your speed
Uh,
is increasing, then your wavelength also
increase.
increase. So which one is showing you increasing wavelength?
D.
Increasing wavelength, which one? What is the way to get wavelength?
Bangladesh.
Bangladesh, your wavelength is here increasing. What is how we get the wavelength? Wavelength is the difference or the distance between two wavefronts, right? Isn't it?
Yes, sir.
You forgot that. The wavelength is the write it in your copy. The wavelength is the gap between two wavefronts. So when light travels from shallow to deep water, wavelength increases as the speed increases. Are you writing?
Yes, sir.
Monica? Monica,
Yes, sir.
your answer was C before.
Yeah. Yes, sir.
Yeah, your answer was C before, and you know it, right? Why it is.
Mm-hmm.
Yeah, Mahi, did you write the notes?
Yes, sir.
What you wrote? What you wrote, Mahi? Hello, Mahi. If you did not write, now you write. The gap between two wavefronts. This is very important. If you know it, then you can apply in every place. Gap between two wavefronts is wavelength. If wave travels from shallow to deep, deep water, then speed increases. Hence, wavelength, wavelength increases. So, have you written now, Mahi? Hello,
Yes, sir.
please write it. Then I will ask you again. Anytime I can ask you. Don't miss writing because tomorrow
Okay,
you'll
sir.
forget. Okay, Monica, please send it in our group. The answer is C. Now you send, huh? Yeah, Monica, are you sending?
Done, sir.
Yeah, good. Then we have for 13. Question number 13 we have. Yeah, Monica, continue this one.
A water wave moves quickly in deep water. The
Hmm.
waves now enter shallow water and its speed decreases, which row shows what happens to the frequency of the wave and what happens to the wavelength of the wave.
Yeah, it's going from deep to shallow. Then what is your answer? Monica, what's your
Um,
answer?
B. Bangladesh.
Frequency will decrease. For the same source, frequency is always same, right?
Mhm.
Hmm.
That does not change.
And it is going deep to shallow.
C.
So
C.
wavelength will not change.
Wavelength will decrease.
Yes. Speed will decrease, wavelength also decrease, right?
Decrease. Yes, sir.
Frequency remains same. Frequency does not change.
Change.
So
It's
Mahi,
C.
Mahi disconnected. Yeah, the answer is C. It's done, right? C.
Yes, sir.
Then it was easy question for you as you got lots of information. Now this one. Yeah. Can you read this?
The diagram represents plane wavefront of a water wave about to strike solid barrier, which diagram shows the position of the wavefronts after reflection at the barrier.
Yeah. Which one is showing you the reflection?
Mm, D or C? C.
Reflection
C.
means returning back
C.
or bouncing back. So it should be C because
C.
in reflection, what happens? Uh, we are following the law of reflection, right? That is angle of incidence equals angle of reflection, right?
Yes,
So
sir.
according to that law, if the water wave is coming in this direction, then it's making one angle with the normal. The same angle should be with the reflected waves, right?
Yes,
Isn't
sir.
it? And for that one, we should have this type of wavefronts where you see the direction of wavefronts will be this. Okay, it's clear.
Yes, sir.
So take the snap of this, then send to our group. Here, C is the answer. So here also you are following the law of reflection. I equals R. Now, next one, 15, right? 15, I'm making it bigger. Yeah, now you read.
A wave moves along the surface of water. What is the wavelength of the water? D.
Wavelength. What is the wavelength of the wave? So what is the definition of wavelength you got?
Mm,
Monica, can you check your notes? What is the definition of wavelength?
The distance from crest to crest or trough to trough.
Okay, so still your answer is Dhaka or you'll change it?
Mm, Answer is A.
Yes, answer should be A, the distance between one crest and the next crest. And the one you chose, Dhaka, what should be the statement, uh, this statement for uh, other quantity? What will be that quantity?
Frequency.
Like your statement you got in Dhaka, for which quantity it match? Is it matching with amplitude or frequency? Which one?
Frequency.
Frequency. Okay. So you are having always time, number of waves passing a fixed point per unit time or 1 second. That one is giving you frequency, right?
Yes, sir.
So till here it was your homework and we are done, right? 6 to 15. And questions
Yes, sir.
16, 17, 18, 19, 20. We did before, right?
Yes, sir.
And structured questions, did we start structured questions that day?
No, sir.
No, no, we did not start the structured questions. So have a try the structured questions. Read question one.
Mm, Some waves are longitudinal and some waves are transverse. State how a longitudinal wave differs from a transverse wave. Mm,
Okay, what is the difference?
um, the vibration of the part in longitudinal wave, the vibration is parallel,
Hmm.
and in transverse it is perpendicular.
Yeah, perpendicular, and you mention, you write it, whatever you said, and with that you add with energy transfer direction. Okay, our standard is where which direction the energy is moving, right? So,
Yes, sir.
so our parallel or the perpendicular, we are saying in terms of energy transfer direction.
Mm,
So you write it, complete it, then tell me what you have written. Okay, Monica,
Yes, sir.
done. Now we have 1B, then we have 2. You see, 2 is very easy, right?
Yes,
Uh,
sir.
2 very easy. Then B also very easy. See, you have to draw diagrams. So you try, huh? If you can't do, you don't do that, but you try. I think some of the things here are very easy, right? Like
Yes, sir.
here,
Yes, sir.
calculate the frequency. You can find from here the formula. Then what is meant by a term transverse wave motion? You can do it. Hmm.
Mm-hmm.
The some of the things are very easy here you can do, and some of the things are tough for you. Those you keep blank. Okay, we will discuss them in next class. So you try, huh? The structured questions from 1B till 5. Okay.
Okay, sir.
Hello, Monica.
Okay, sir.
The same idea we are getting here, the one you got in MCQ questions. So you can have a try. Yeah, you had lots of questions done already. We did 20 MCQs, and there you got lots of information. In notes you got information, so you try with your information. If you can't, then we'll discuss, okay, in next class. And today we are not going anymore, okay, because I have a school meeting. For that I have preparation, okay. We will continue in next class. Okay, Monica, thank you for
Yes, sir.
joining. Thank you. Thank you so much, Allah Hafiz.